sets, relations and functions. Now the reason why these three chapters are studied together is because when we talk about sets and then we talk about relations, what is relation? Relation is a means to relate to sets, right? So we say relation from one set to another, or it can be relation on the same set. And some relations which are of special types, we'll discuss in some time, are called functions. And functions, let me tell you, are going to form a big part of your calculus syllabus. Because calculus is all about applying operators. Limit is an operator, differentiation is an operator, integral is an operator. So all these operators are going to act on functions, right? So it becomes very, very important for us to understand functions, and to understand that we need to understand relations, and relations are applied on sets, and hence we need to understand sets, right? Let me tell you, this topic is not very important with respect to your school exam. JEE obviously asks some questions on sets, but it is always along with topics like probability, permutation, combination, all those stuff.
Probability is like a very important topic. Is probability an important topic?
Very important. Very important.
Oh, in terms of permutation, combination.
Yes. So PNC and all, which is finding a lot of uses in probability, sets will also be used. So this topic that you have right now, probably because of your school duties, it's important. But in general, they come along with other topics. So let us start with sets. Now you already know it. Okay. So how do you define sets? What is sets?
A set is a collection of a well-defined collection of objects.
Exactly. It's a well-defined collection of or aggregation of distinct objects. Okay. Now, well-defined is important, right? You would have heard the word sets along with kitchen set, sofa set, cutlery set. Why do we call them as a set? Because all the items which are in that set are of well-defined nature. For example, when you see a sofa set, the 3 pieces and the 2 pieces, they look identical, right? Like cutlery set, the spoons all look identical, right? So, yes sir. So, only when your objects are well-defined, it will be called a set. To give you an example of a collection of objects which may not be well-defined, is like collection of all intelligent students. Now, is intelligence a well-defined parameter? No. Right? We cannot say it's a set. A collection of wild animals. Is wild a well-defined thing? No. I may find a dog wild, right? While many people have
a cheetah could be domesticated.
Cheetah could be domesticated, right? So it should be well-defined collection of distinct objects. Now why distinct? It's because in a set we do not write any element repeatedly. Every element is written only once. These things are all known to you, so I'll be a little faster in the sense I'll just spend more time on things which are important. Share also. Set is written by a capital alphabet and the elements of the set are written within curly brackets. Okay? Please note, when you say curly brackets means the elements are not assigned any order. In the sense, if I write a set having 1, 2, 3, 4, 5, it is the same meaning as writing it as 2, 3, 1, 4, 5. It doesn't make any difference. Okay? However, if you write, let's say, a set of elements in round brackets, then you are calling it as an ordered set. Then you cannot displace the position. For example, coordinate when you write of a point 3, 4, we cannot write curly brackets here.
Yeah.
Okay. And here, x coordinate is 3, y coordinate is 4, you cannot change their position. Then it will make a different set of points altogether. Now, what are the means of representation of sets? We normally use 2 ways to represent a set. One is called
Set builder and
set builder form and draw. So means of representation of sets. Means of representation of sets. It is primarily represented in 2 forms. One is called the roster form, also called the tabular form, also called the enumeration form. Anything you can call it. And the other one is the set builder form.
Sir, no other terms for set builder form.
This is called set builder form. Yeah. Now, what is a roster form? You see an example over here. This is a roster form where you enumerate or list out or tabulate the elements. By the way, these are called elements of the set. Okay? The symbol that we use to denote that a particular entity is an element is belongs to. We'll say 2 belongs to set A.
Can I drink water?
You can eat, you can drink water, but you cannot talk. Only I can talk. Okay? So this is called the roster form or the tabular form or the enumeration form. Now when set starts becoming big, it is very difficult to actually list out all the elements in this way. So if you write the element of a set by stating the characteristic of the element there in the set or stating the pattern in the set, that means you are writing it in something called the set builder form. So same thing if I write a set A containing all elements x such that x is a natural number and x is less than equal to 5, then this would become the set builder notation for the same set. You are all aware of it? Can we take up a quick exercise on set builder and roster form? Okay. Not many questions, just few ones I will take.
Yeah, this is
Write the set builder form for the following.
Okay, that's the next one.
Please don't talk, please don't talk. Yeah. Give me the set builder form for these 3 sets. You just have
I won.
6 minutes to answer this.
6 minutes? Sir, that's too much.
Too much, okay?
3 minutes.
3 minutes. Good. I hope you have got the attendance sheet, or at least it is circulated.
It's only 3 days.
Yeah. See, we are mostly going to spend time on the cardinal properties of sets and the proving of the operations on sets, because that is important. Done? At least first one is done, so wait.
Yeah, first, second.
Sir, all done.
Can you discuss the first one? Can I say for the first one?
Yeah.
Now there are various ways. I've seen people writing like this. X such that. X is, tell me.
Natural.
Okay, X is natural number, then
Then x by x square plus 1.
Then
X by x square plus 1.
okay.
Sir, inside.
Then you should write it here itself.
Yeah, that's it.
Okay.
Sir,
X is x square plus 1 and x should be less than equal to
4.
Yes, you were saying something.
Or could we define it in terms of another variable n, so that x
That's what.
such that x is equal to n over n squared plus 1.
Right, you can also do that. That's why I said people follow different approaches. Some people write x and they say x is equal to n by n square plus 1, n being a natural number less than equal to 4. Some people directly write it over here itself.
It has x cube plus 1, right?
Wait, I'm supposed to ask. Yeah, whom should I ask? Dedas, second one. There's no time. Yes, Ashutosh.
So x cube plus 1 belongs to expand.
Correct. X cube plus 1 such that x is a natural number
X is less than or equal to 5.
less than equal to 5. Very good. Last one.
Sir, it's a little bit long.
Yeah. No, it's very short. It's very
It's a
short.
little bit
No, it's a very short one.
x
Don't give an explanation like okay this is
such that
this.
xn is equal to xn minus 1 plus n, x1 being equal to 1, n belonging to n lesser than or
Sir,
equal to 6.
2 is said, that's all. 1 plus x into x plus 1 by 2. 1 plus x into x plus 1 by 2 and x is less than 6. Yeah, less than or equal to 6.
Genius.
If I put x as 1, the first term will become 1 plus 1 plus 1. So it should be 3, right?
Oh no, 1, if you put x is equal to 1 here, it will be 1 into 2 by 2. So here it will be 1. 1 plus, sorry. 1 plus this.
So it should be 2, right?
Yeah, no, this is 1. Okay, then minus 1. X minus 1, yeah, now it's perfect.
Okay.
X minus 1. And it will be, yes.
Putting 2 should be 2. Putting 3 should give me 4. Putting 4 should give me 7. Absolutely correct. Third one is slightly tricky. How many of you are able to crack it apart from Sukrit? That is also correct. But I would appreciate if you just give me a single formula like this so that you are able to generate it just by putting your x as 1, 2, 3, 4.
So 1 second.
Now at least do you see some pattern over here?
Yeah.
What is the pattern?
Plus 1 plus 2 plus 3.
The pattern is I generate this term by adding 1 to this. I generate this term by adding 2 to this.
How do you
I generate this term by adding 3 to this term by adding 4 to this, right? Yes or no? Yes or no? So the difference itself is actually in AP. Yes or no? The difference of the terms is actually in AP. Why don't you girls come here? Khyati and Raksha.
isn't that called something?
It's too far.
So aren't those set of numbers called something? 0, 1, 1, 2.
Fibonacci.
Are you trying to talk about Fibonacci sequence? No, this is not a Fibonacci sequence.
Yeah.
Now, how do we crack this? Now, just for this example, I am telling you a method which is called the method of difference, which anyways you will be studying later on in the chapter sequence, series and progressions. Okay? So, the formula that you get, I'll be finding that formula in a very simple way. Should I erase the top two? Can I erase the top two? Alright, let's say these numbers I want to add them. I will not actually add them. I'll just pretend that I'm adding them.
It's fine.
Okay. Now,
This part
let's say the nth term is Tn. My main aim is to get the nth term. Because if I'm able to find the nth term, I'll be able to represent the value of any term by just stating the position of the term, isn't it? Isn't it? Now let's say I'm writing S as the series of these terms. Let me write the same series, one shifted to the right.
Okay.
One shift. Oh yeah, I'm going to subtract.
So
Alright.
use a similar method for
Okay.
solving
Is this okay?
ADP, right?
Now let me subtract both of them. Right. You use the similar method in ADP. Let me subtract them. What is S minus S? S minus S? 0. If nothing is there, assume it to be 0. If nothing is there, assume it to be 0. So 1 minus 0 is 1. 1, 2, 3, 4, 5, 6, till Tn minus 1 minus Tn.
Oh, okay.
Okay? Let me get this last Tn to the left hand side.
Wait, that's not.
Okay? Till this term. Now, barring the first term, do you see that the last terms are in AP?
Oh, okay, that's very
Whose first term is 1,
That's quite good.
common difference is 1, and how many terms are there?
N.
Think carefully. From this position to this position, how many terms would be there?
N minus
N minus 1 terms are there. How many terms are there? N minus 1. So please pay attention over here. Aware. So we are dealing with an AP whose first term is 1, common difference is 1, and number of terms are N minus 1. So by the virtue of knowing AP in your class 10, what is the sum of N terms?
N by 2 to N.
Especially what is the sum of all natural numbers from 1 to N? N into N plus 1 by 2. If I am summing it till N minus 1 terms, it would be what? N minus 1 into N by 2.
Yeah.
So can I say your nth term will be 1 plus N into N minus 1 by 2?
Yeah.
So can I write the set builder form for this as 1 plus N or 1 plus X into X minus 1 by 2 such that X is a natural number and X is less than equal to this. Please sir. Make sense?
Yes, sir. Yes, sir.
This method is called the method of difference.
Sir, it should be X less than 7.
How many terms are there? 7. Okay. Make it 7. Is that okay? Anyways, till this complexity level may not be asked, but of course you should be knowing some of the methods. Maybe in JEE. Huh?
You can do it in a different way.
So there is
Different way is what
It's a little complicated, but you can do it.
Sir, will they like ask?
Sir, it's actually not that bad, sir.
Not that way.
All you have to do is specify what is the x plus x n term in terms of x n minus 1 and specify the first term. Then you can
Will
be
we asked to
asked.
solve it? Will we be asked to solve something like this?
No, that's it. We have done it.
No, will we be asked to solve?
No,
Now it's true, already has radius like it is.
maybe yeah. Now let's talk about types of sets. Let's quickly move on. Chapter is easy, so there's no point, pulling it, extending it unnecessarily. Really?
But we haven't done it in deep. Like what
Right,
is
simple.
extremely.
So you can go a little faster.
Very fast.
Yeah.
Okay.
Sir, it's fine if we go 100 miles an hour, so we can handle it.
Yeah. Yes. Not for you. Okay.
It's over up here.
Now types of sets. I'll not waste too much time on types of sets. There are a few sets which are very, very important and you should be knowing them by their name. Null set. What is a null set?
No,
A set which is empty, right? This is called a null set, also represented as a symbol 5. Correct? Okay. What is a singleton set?
Only one.
Yeah.
Singleton set is a set having only one element A in it. Okay. Can you give me an example in set builder form which will result into a singleton set?
Set
X such that x belongs to n and x is between 4 and 6.
Yeah.
Okay. Or can I say
X is the
even prime number, right?
Yeah.
Give me a set of all even prime numbers, that would be a singleton set having only 2 in it. Okay. A set of all planets where life exists.
Sir,
I know you say it is not well defined clearly. Okay, right now Earth, but maybe more possibilities are there.
and sir, we don't know what constitutes life.
Next, we'll talk about finite set. What is a finite set?
Then X is
When they have a finite amount of elements, right? The number of elements in a set is called the cardinal number of a set, right? Written by NA, right? To give you some examples of finite set, set of all vowels in the English alphabet, that is a finite set. What would be an infinite set?
no vowels.
Infinite set is a set having infinitely many number of elements, right? Set of all natural numbers, set of all whole numbers. Even the intervals that you study. For example, if I say close interval 1 to 2, this is an infinite set. It has infinitely many number of elements, right, in it. Right? All real numbers between 1 and 2. So basically, the intervals that we were studying in our maths before, they were all sets. Is that okay? Moving on.
Except why?
What is equivalent set?
Same number of elements.
Same number, same cardinal.
Alright. Set A and set B will be called equivalent sets if they have the same number of elements. What are equal sets?
Equal sets if every element in A belongs to
Please remember this. I'll be talking about later on also. When you say two sets are equal, it implies A is a subset of B and B is a subset of A. Only when these two criteria are met, we say a set is equal to another set. Please remember that. When you say set A is equal to set B, it implies A is a subset of B and B is also a subset of A. Then only the two sets can be said to be equal. Why I am telling you this and why I am emphasizing this is because later on when I give you a question to prove one set is equal to another, please note the elementary way to prove it is to show one is the subset of another and the other one is the subset of the other one. We will be taking more examples based on this after we have done the laws and operations on sets. Okay. The very important type of set that we need to study is power set. Who will define the power set? What's the power set?
The set of all subsets of a set.
Okay. Now to study power set, we first need to talk about subsets. So let's first talk about subsets and then we'll talk about power sets. Can I erase this one?
So why did you guys just write in bracket 1 and 2 in front of infinite?
Sure, this one. Implies and is implied by.
No, for the infinite set. Next to it you wrote in square brackets 1, 2.
That's an interval which has infinitely many elements. I should not write it exactly like this. I'll tell you how to write it.
Interval between 1 and 2. Both included.
If I say
This we got.
a set A is containing X says that X is a real number
It
and X belongs to this, it will be an infinitely big set. Alright, so before I talk about power sets, subsets is something which I am going to discuss. Again, very important part. You may get a question on subsets in school. Okay. Can I erase this? Yes. If let's say I say B is a subset of A, what does it mean?
All elements.
All elements of B belongs to A. Are you getting this point? And B is called the subset of A will be called the superset of B. Is that okay? Now, to give you an example of the subsets you can form, let's say I have a set A which has element 1 and 2. Then your B can possibly be null set, a set containing 1, a set containing 2 or a set containing 1 and 2. So the 4 subsets here are possible from this set. And you would have also learned in your school that the number of subsets possible, the number of subsets is basically given as 2 to the power NA, where NA is the cardinal number of the given set. Is that okay? Can somebody tell me why it is so?
Sir, basically what happens is that we'll cycle through each and everything. We have 2 choices for each and every element.
Exactly.
We accept or we reject it.
Correct.
So for each there are 2, so 2 times 2 times 2.
Right. So basically, as he said,
One more thing.
Yeah.
You can even use binomial theorem.
binomial theorem for that.
Yeah, so first you have to choose
NC0
one.
plus NC1.
Yeah, NC1 plus NC2 will be 1 plus 1 to the power of n and will be 2 power of n.
Right, 1 plus 1 to the power of n. That binomial theorem and permutation combination leads to the same answer. See, the reason that he gave is the number of subsets possible from this set can be found out by using the fact that every element has 2 choices. To be a part of the subset or not to be a part of the subset, right? To be or not to be, right?
That is the question.
So this has 2 options, this has 2 options, and according to fundamental principle of multiplication, in fact fundamental principle of counting, we have to multiply it. So 2 into 2, that is 4 ways you can make subsets out of it. Please note that the set itself is not a proper subset. Okay? Normally there is a controversy around this. If you see R.D. Sharma says the null set is not a proper subset and the set itself is also not a proper subset. They are called improper subsets. But if you go into the discussions on the forums like MathStack and yeah, all those websites, they will say only the set which has at least one element lesser than the set given set A would be a proper subset. So ideally null set should also be a proper subset. But that depends upon what has been conveyed to you in your school. And have they talked about proper subsets and improper subset? No. Yeah, okay. So what R.D. Sharma says, the null set and this set is the improper subset. Rest all are called the proper subsets. Sorry? The set which contains lesser number of elements than the original set should be ideally called the proper subset. If it is equal to the number of elements, it will be improper subset.
Sir, but then how is it decided? Sir? Is there like a ice bag? Is there a live PAM to decide everything?
There is.
What have they said on this topic? They just did a meeting on it.
See, I tell you, in most of the countries, 0 is counted as a natural number.
What?
Yeah.
Zero is natural.
In some of the countries, 0 is counted as a natural number.
So there is no difference between whole number and
Right? Again,
My whole life is like.
until it starts paining, they don't try to make it distinct. Okay. Now here, proper subsets are, I would consider these 3 as the proper subsets, and proper subsets would be represented by the symbol this, without an equal to sign. Okay. So number of proper subsets is 2 to the power n minus 1, excluding the set itself. Okay. If you consider R.D. Sharma definition, then phi and the set itself would be excluded. So number of subsets will be 2 to the power n minus 1 minus 2. Normally the word proper is also used in proper divisors. We say 1 and the number itself are not proper divisors. So to a certain extent you can follow what R.D. Sharma is saying, right? So according to R.D. Sharma, only this is going to be the proper sets. Rest, these 2 are called the improper sets. So these 2 are proper, these 2 are improper. Okay. However, this is not going to bother you much. Let's have a question on this. Write down. Let me tell you guys, when a set itself is made up of elements which are sets, be careful about choosing your notations. Okay. So before I give you a question, let me ask you a simple question. Can I resist? Can I resist?
Based on Ashish.